When you look up at the night sky, you see a tapestry of light. Thousands of stars. The band of the Milky Way. Telescopes reveal billions of galaxies, stretching out in every direction. It looks crowded. It looks uniform. Scientists call this the cosmological principle, the idea that the universe is the same everywhere. No matter where you stand, the density of stars and galaxies should be roughly equal. But there has always been a problem with this theory. When we measure how fast the universe is expanding, the numbers don't match. When we look at the distribution of matter, something feels off. For decades, we thought it was just a measurement error. But recent studies suggest a far more disturbing reality. The reason the universe looks strange to us is not because our telescopes are broken. It is because of where we are. We are not in a normal part of the universe. We are in a desert. New evidence suggests that our galaxy, the Milky Way, is drifting near the center of a massive region of emptiness. A supervoid, 2 billion light-years wide. We are living in a bubble of nothingness, surrounded by a shell of distant, dense galaxies. We are the castaways of the cosmos. Welcome to the dark. I am Stellar. Today, we are going to explore the KBC Void. We are going to find out why our galaxy is so lonely and what it means to live in the largest dead zone in the observable universe. To understand the void, you must first understand the crisis. Right now, astronomy is at war with itself. It is called the Hubble Tension. Here is the problem. We know the universe is expanding. We measure this expansion rate using a number called the Hubble constant. But when we measure it, we get two different answers. Method 1. We look at the early universe, the cosmic microwave background. This tells us the universe should be expanding at 67 kilometers per second. Method 2. We look at the local universe, nearby supernovae and Cepheid stars. This tells us the universe is expanding at 74 kilometers per second. This shouldn't happen. Physics doesn't change just because you look closer or farther away. It's like measuring a child's height and getting 4 feet, then measuring it again with a different ruler and getting 5 feet. One of the rulers is wrong. Or, the child is changing shape. For years, scientists panicked. Is our understanding of gravity wrong? Is dark energy getting stronger? But in 2013, 3 astronomers, Keenan, Barger, and Cowie, proposed a solution that is both elegant and terrifying. They said, the rulers are fine. The physics is fine. The problem is us. The reason the local universe looks like it's expanding faster is that matter is rushing away from us. Why would matter rush away? Because we are in a hole. Imagine a block of Swiss cheese. The holes are empty voids. The cheese is the dense cluster of galaxies. Gravity pulls matter from the empty places toward the dense places. If we are living inside one of the holes, the galaxies around us are being pulled away towards the dense walls of the void. This extra speed makes the expansion look faster than it really is. It fixes the math. But the cost is existential dread. It means the Milky Way is sitting in the middle of the largest underdensity of matter ever discovered. The KBC Void. Voids are not rare. The universe is structured like a cosmic web. Filaments of galaxies connect nodes, and between them are gaps. But the KBC Void is a monster. Most voids are small, a few 100 million light-years across. The KBC Void is 2 billion light-years in diameter. It is roughly spherical, and we are within a few 100 million light-years of the center. Inside this sphere, the density of matter is about 20% lower than the cosmic average. 20% doesn't sound like a lot. But on a cosmic scale, that is billions of missing galaxies. Trillions of missing stars. It means that if you could travel 3 billion light-years away, outside our bubble, the universe would look drastically different. The sky would be brighter. The gravity would be stronger. The galaxies would be closer. We are living in the cosmic equivalent of the Sahara Desert, while the rest of the universe lives in the rainforest. This isolation distorts everything we see. We built our laws of physics based on our view from this location. But what if our view is biased? What if we are the exception, not the rule? We are studying the ocean by looking at a single drop of water in a dried-up puddle. And the scary part is, we aren't the only ones trapped in these holes. If you want to know what a true, void looks like, we have to look 700 million light-years away, toward the constellation of Boötes. Here lies a region so empty, it is often called the Great Nothing. The Boötes Void is a sphere 330 million light-years wide. By volume, it should contain over 2,000 galaxies. We have found 60. Imagine a sphere of space so vast that it would take light 330 million years to cross it. And inside? Silence. 60 lonely galaxies drifting in the dark, separated by tens of millions of light-years of absolute vacuum. Astronomer Greg Aldering once said, "If the Milky Way had been in the center of the Boötes Void, we wouldn't have known there were other galaxies until the 1960s. Think about that. If we lived there, our telescopes would have looked up and seen darkness. We would have thought the Milky Way was the entire universe. We would have thought we were truly, absolutely alone. No Andromeda. No Hubble Deep Field. Just us, drifting in black ink." How many civilizations are trapped in the Boötes Void right now? Looking up at a black sky, thinking they are the only things in existence? The KBC Void is larger than Boötes, but it is less empty. We still have neighbors. But the walls are closing in. Gravity is draining our region. Over billions of years, the voids get emptier. The clusters get denser. We are being slowly evacuated. But there is a void even stranger than the KBC or Boötes. It is called the Eridanus supervoid. And it might be evidence of another universe entirely. In 2004, satellites mapping the radiation left over from the Big Bang, the CMB, found a cold spot. A massive region in the southern sky that was significantly colder than everything around it. According to the standard model of the Big Bang, this spot shouldn't exist. The early universe should be uniform. The leading theory? It is a supervoid, a hole nearly 1.8 billion light-years across. Because there is no matter there, the light from the Big Bang has to travel through vast emptiness. It loses energy as it climbs out of the gravitational well, cooling down. We are seeing a ghost shadow of a missing structure. But some physicists have a darker theory. They suggest the cold spot isn't a void. It is a bruise. They propose that billions of years ago, our universe collided with another bubble universe. Like two soap bubbles bumping into each other. The collision pushed matter away, creating a dent in reality. If this is true, the Eridanus supervoid is the impact crater of a multidimensional car crash. And we are staring right at the scar. We often talk about gravity as a force that pulls. The Great Attractor is a gravity anomaly pulling our galaxy toward the Centaurus cluster. We are flowing toward it like a river. But recent maps of the local universe revealed something shocking. We aren't just being pulled. We are being pushed. Directly behind us, in the opposite direction of the Great Attractor, is a region of space that seems to repel matter. They call it the Dipole Repeller. Gravity doesn't push. So what is happening? It is a void. Because the Dipole Repeller is so empty, it has no gravity. The dense regions on the other side of us strip the galaxy away. It creates the illusion of a repulsive force. Imagine standing on a hillside. You feel like you are being pushed down the hill. But really, gravity is just pulling you, and there is nothing behind you to hold you back. We are sliding downhill. Away from the void. Into the cluster. This confirms the KBC theory. We are caught in a cosmic flow, evacuating the dead zone, running from the emptiness. But we can never run fast enough. Dark energy is expanding the voids faster than we can move. Eventually, the clusters will be ripped apart too. What does it mean for life? If we are in a void, does that explain the Fermi paradox? We ask, where is everyone? Maybe they are all in the dense regions. Maybe the cities of the universe are in the superclusters, where galaxies brush shoulders and civilizations can hop from star to star. We are in the rural backcountry, the Badlands. The distance between us and our neighbors is vast. Perhaps we haven't heard a signal because nobody bothers to broadcast into the void. Why scream into a desert? Or perhaps, the void is a quarantine. A natural barrier that keeps us safe from whatever monsters lurk in the high-density clusters. In the three-body problem, there is the concept of the dark forest. The idea that silence is survival. Maybe the void is our camouflage. We are hidden in the dark, safe, alone. But isolation has a price. When the universe eventually dies, when the stars burn out, the voids will be the first places to go dark. We will be the first to forget the light. The KBC Void teaches us a humbling lesson. We thought we were normal. We thought our view of the universe was standard. But we are anomalies. We are floating in a bubble of emptiness, drifting away from the rest of creation. The next time you look at the night sky, remember, the blackness between the stars is not just empty space. It is a wall. It is a distance so vast it defies comprehension. And it is growing. We are alone in the dead zone. And the silence is deafening. Subscribe to Stellar's Dark. Join the void. And tell me in the comments, is it better to be alone in the quiet dark or crowded in the chaotic light? I'll see you in the next dark.